Now what is the life of a thread is very important here with respect to the join method. Think that I have created what? I have created, what is that? PWFC. F is equals to new PWFC. An instance, that is a thread has been started. I mean it has been born, but it is not yet been in runnable or ready state, or it is not yet be in the running state. Okay, so what is happening here? What is happening here? It is in ready or runnable, sorry, it is in new or born state. Okay, understand this one. After that, if I do call start method on this instance, what is going to get happen here? Here we are going to see this particular thread to be in which state? Ready or runnable state. Okay, and after that, what is going to get happen? If thread scheduler allocates the processor for our thread is going to be in. Our thread is going to be in. If thread scheduler allocates the processor or CPU, allocates the processor, okay, or CPU, then it will be in which state? A running state. Okay, it is in running state. Now it is fine. Fine, boss. Till here it is fine. Now we are going to get what? We are going to call join overloaded methods. And one more thing, I didn't discuss about join overloaded methods. When we have to use the join overloaded methods, right? I will tell. See, we are having three methods, right? What are those? Public, final. Okay, public, final, void. What is that? Join method without any arguments. Throws what? Interrupted exception, right? Checked exception. Okay, now try to understand this one. Public void, public final void, join having argument as what? Long milliseconds, which also throws interrupted exception. Public final void. What is this? Join long milliseconds. What's the other one? Int nanoseconds. Okay, 1000 nanoseconds is 1 microsecond. 1000 microseconds is what? 1 millisecond. Okay, that's very, very important. And 1000 milliseconds is 1 second. 60 seconds is 1 minute. Okay, we are going to discuss that one in our some other things. Okay, now this is the prototype of our overloaded join methods. So if you do call any of the methods here, okay, what is going to be happen here? If you do call this particular method, join method, which is having no argument, we are going to get the deadlock situation, right? Now see here, in these three scenarios we have seen the deadlock, right? So guys, sir, you have done a very good thing. Please, will you show me how to avoid that deadlock? It is so simple. You just put waiting time for these join methods. See, first let me explain this one. Here we are going to avoid the deadlock situation, and also here we are going to avoid the deadlock situation. How means you have to use the overloaded join methods. So let me take the join that is waiting for how much time? Let me take that for like 5 seconds or 6 seconds. Okay, try to observe that one. It is so simple. I am going to use the overloaded join methods. Please understand me. Okay, now let us go for that piece of code here. Okay, main thread, it is in main method. Okay, p dot join. So it is going to wait until how many seconds? Like let it be like 6 seconds. Okay, 6 milliseconds. Okay, not 60. Okay, now where is the other one? T dot join. Okay, please bear me for 10 or 5 minutes. Okay, 5 or 10 minutes. Okay, 6 milliseconds. Okay, now we are not going to see here, still it is in deadlock. Only let me terminate. Let me execute this one. Sorry, I have rechanged the source code. Okay, let me compile this one and let me run this one. You can just check it here. Currently it is in deadlock situation. Okay, both the threads are waiting for a particular period of time. After the waiting time has been completed, now the things has been changed. Okay, now the child thread has been got the chance, and now what is this? Other thread which is going to wait for once again for which time? For 6 seconds. After it is going to give the output to us. Okay, now let us check that one. Now it is going to give the output to us. Okay, what happened? It should give the output to us. Where is that? Here start method is there, right? It is going to wait on this one. Okay, of course child thread, and what is this? P dot join, it has to come. So actually this piece of code should get executed, but why it is giving deadlock situation? Let us trace the code, guys. Okay, let us trace the code. Here if you do check this one, P dot start, fine. And what is this? P dot join, parent thread is waiting until child thread execution gets complete. But as a dummy person, I put this code, this piece of instruction as it is. Let me comment this one. Now let us go and recompile and re-execute this one. There won't be any deadlock situation. Please try to understand this concept. These are all very important. Whenever you do put your code in your laptop, put that only in notepad so that it will be very easy for you. Now you can just check it here. It has been not in deadlock situation. See, I have used the same piece of code here. P dot of join, but what? Only overloaded methods. And let me show to you the other one also. A thread calling join method on its own reference, and there also we are going to take overloaded join methods. Okay, let it be like L, and other one is what? Int, right? Int, like let it be like 999 nanoseconds. Now also there will be hang for our application for a small period of time, but where we do call this one after child thread, right? So we will be getting first child thread data, later you will be seeing this one, or else it will be having some unpredictable data after completion of time. Okay, try to observe that one. Okay, now I am child 1, child 2, child 3, child 4, child 5, and it will wait. Main thread is waiting, but we have used overloaded method. That's why our application is not going to be in deadlock situation. Okay, now parent thread 1, parent thread 2, and parent okay, what is happening here? See here, we have used that join method where? Within the while loop right here. That's why for each and every iteration it is going to wait for 6 seconds plus 1 second, 7 seconds. Okay, no need to worry. It is small piece of code, it is going to get terminated. But please understand the concept at all corners. That is what the main intention of these sessions. Okay, now we have overcome the deadlock situations. Now please try to observe this piece of code, guys. Okay, I mean this life cycle of what? Our thread. Okay, let me put this one. What is that? New or burn state. Okay, new or burn state. Now at the time of running a thread, we are going to call what? Join overloaded method. So now what is going to get happen here? Okay, join, which throws interrupted exception. Other one is what? Join overloaded method, which is not it is not native. Don't get confused. How the native methods are? First yield method is native method, at last thread is the native method. Okay, still we didn't discuss yield, right? Let me put that one to you later. Okay, no need to get confused. Okay, it is also throwing. So now whenever there is call of these three methods on a particular thread reference, the thread is said to be going to, it is said to be going to waiting state. Okay, then the thread will be at what state? Waiting state. Okay, now try to observe when the thread is going to get executed once again. When the thread is going to get executed, it depends mainly on thread scheduler as well as how this thread is going to come out of the waiting state. That is important to us. Now see here, what is going to get happen? If see here, think that on thread 1 we have called all these methods, and thread 2 is the main, let it be like T2 is the main thread. Okay, and what is that? T1 is the child thread. Okay, so it is what? Child thread. Okay, understand that piece of point. Okay, now thread 2, or else let me put like this. Most of the guys are doing mistake here. Let me give some small hints to you. Okay, so thread 1 is main thread. Okay, and it is calling these methods on whom? T2. Okay, on T2 we are going to call all these methods. Okay, and what is that? Main thread is executing all these join methods on T2 reference. What is T2 here? Child thread. Okay, it is what? Child thread. Okay, now T1 is executing all these methods. Now when this T1 is going to come out of waiting state after completing the execution of child thread, that is T2 thread, right? If T2 completes its execution, now it is clear, right, for you according to the concept. If T2 completes execution, okay. And now when it is going to get chance again when the time expires. We have seen that one, I have shown to you with example. If time expires, okay, if waiting time expires, that's very important guys, please make it as a notice. And other one is what? If T1 get interrupt and T1 get interrupt. This example I didn't show to you, I will show to you with one very good example, but after completion of this life cycle, okay, that is very important. See here what is going to get happen here. So when the thread is going once again coming out of waiting state, it will be at ready state. Now it will come to the whether if thread scheduler allocates the processor, it will be coming into running state. In case whenever you do call these join methods on a particular thread reference, then it is going to the waiting state. If you are not calling any join methods, it is going to be where? After completing the run method, it is going into dead state. That's very, very important, okay. After completing the run method execution, it is going to be in which state? Dead state. That's it. Thread job has been finished, okay. Dead state. That's it, okay. That's it. This is the life cycle or life of a thread with respect to the join method, okay. But I didn't discuss about this T1, right? This is very, very important. Try to focus on this one, okay. Just have a look over this one. Now we are going to discuss if waiting, that is the thread which is waiting get interrupt means this will be the output. There you are not going to see very good output, okay. I am going to show that small piece of code here. It is so simple. You have to understand the concept at all corners, okay. Now let us go for that particular thing guys, okay. Let us go for that particular thing. It is so simple, okay. So now let us discuss about that if the waiting thread is waiting means, that is a particular thread is waiting means, if it get interrupt means what is going to get happen. Let us see a piece of code, that one technically, then only you will understand. Honestly speaking, what is going to get happen? See, look at over this one. If a thread, that is T1 is the main thread, whatever in life of a thread with respect to the join method, whatever I have shown, the same thing is going to get happen but in different way. If it is waiting means join means it will enter into the waiting state. If T1 is waiting means if it get interrupted means what is going to get happen? Once again it will come into the ready or runnable state. If thread scheduler allocates the, if it allocates the processor means it will execute the run method from where it has been stopped. That is very, very important. That's why I put the heading as what? How to resume a thread and how to re-execute a thread from where it has been stopped its execution, okay. Now it will give the allocation, it will allocate the processor, okay. It will thread scheduler allocates the processor, sorry, okay, it allocates the processor, okay. And it will go into the running state. It will execute, think that it is the run method. Till here it has been executed, and after that getting the chance for second time, it will execute from this point onwards. If this is, and after that it will execute all the lines of code. After that it will go and it will complete the execution of run method. After that it will go into the dead state. And in case if there is a chance of calling once again join method here, it will enter into the waiting state. It will wait until completion of other thread. That is what I am going to explain here. You have to understand these advanced levels of multi-threading. Very important. In your RTS, that is in real-time system applications, we are going to develop the codes based on this one only. Okay, now let us go and develop the code for that one. What is that? Let me take the class. So simple code, but we have to use the brain. That's it. Okay, class PWFC extends what? A thread. Okay, now public static void main string aux. Let me take what? PWFC, P is equals to new PWFC. So here which thing I am going to take here means I'll make child thread. I'm going to make child thread to wait until completion of parent thread. Which thing I am going to consider here? Child thread waiting until execution of what? Parent thread. At the time of waiting, there will be an interruption. So that what we have to use? Interrupt call. We have discussed that one, right? Same thing. Please understand me. Okay. Child thread waiting until completion of what? Until completion of main thread. Okay. That's what the same scenario, meaning that child thread has to call join method on the main thread reference. How to get main thread reference? We have to use current thread, so that we are going to create a thread instance within the thread instance, that is main thread instance within the main thread instance. It is going to be act as the contained object in the container, and whatever you do call methods, it is going to impact on the what? Contained object. I have said to you in my earlier session, please focus. Okay, nothing great here. Even the twist points we are highlighting. Thing is, you have to remember those things. Use a little brain. Okay, now let us go for that one. Okay, so let me take one static variable of type thread T. Now just do this one. What is that called? Current thread, which is the static method in our thread. So that through inheritance I can call this one. No issue. No need to call even on thread class. I mean thread dot current thread. Okay. Now it is going to create what? It is going to create the thread which is executing this method. That thread instance it will call. Who is executing here honestly? Main thread. Main thread instance it will create and it will return what? Thread instance. Okay. This is which type? It is main thread. Okay. Let it be like main thread. And this instance is going to be holded by one of the reference which is available in the thread instance. So which is that? It is the container. It is what? Container. Sorry, it is contained object. It is what? Container. Container means what? Which contains. It's very important. This and all some of the very depth, very good concepts. If you enjoy this one, you can feel very comfort in multi-threading. Okay. Now it is going to return what? This thread instance. So if I do call any method on this thread reference means it is getting referred by one of the identifier of type thread. Now if I do any method on this T, that will impact this contained object. Okay. Try to understand. Okay. Now let us go for. Now let us go for what? Our actual piece of code. Okay. Now that thing happened. Now what I am doing here is p dot start. Now come to the public void run method. Okay. Now the main mystery is going to get happen. Child thread waiting until completion of main thread. Now see here. How to get child thread reference in my run method? In our run method, we have to use this static reference. Before this piece of code executes, we have assigned this current thread reference to this type thread, thread type identifier, right? T. So now I can call happily like what? T dot join. But what is our scenario here? It has to interrupt. If waiting thread is getting interrupt, okay, of course I am changing the scenario here. What is that? Here if T2 here, T1 is what? Child thread. Okay, made it as child thread. Child thread calling these methods on which one? On main thread. Okay, on main thread. Okay, main thread. Okay, don't get confused. Please use the brains. We are bold enough to understand all these things. Okay, now that thing is happening. Now I want to interrupt this one. We have discussed the interrupt method with all the scenarios. We have covered all the corners of that particular interrupt method. Please understand now. Please understand, please. Okay. Now call after starting a thread. We have to call interrupt method. Before starting a thread, if you call interrupt method means it is going to get waste. Right? I have said that one. Please refer my earlier session with great analysis. We have done that one.